Okay. All right. So basically now I've got b squared equals all of this. So b squared equals this point. Actually, I'm going to go ahead and divide that. Actually, you know what? I'm going to leave it as is for now. Okay, so now I've got this divided by that, and I want to square root both sides. Point 0.01875. Oops, sorry, I want to square root that. So square root 0.1875 divided by 0.75, and you see it's 0.5. So b equals 0.5. Okay, so that's the b value. Okay, and by the way, if the b value is less than 1, that means you're going to get a decay. It means it's a decrease. Okay, the last step is I just got to figure out a by plugging that 0.5 into one of the equations. So I'm going to take this equation, the first one I made, and plug that right in. Okay, and that will give me the a. So now 0.75 divided by, oops, or 0.75 divided by 0.5 cubed. Okay, so that's 6. So a equals 6. So now that I got b, and now that I've got a, now I can write out the equation. 6 times 0.5 to the x is my final answer there. Okay. So now to recap. What I did is I plugged in each point into the formula for that exponential equation, x and y, and I got a by itself. I did that for both equations, and I made them equal to each other. And then what I did is I multiplied both sides by the b that has the biggest exponent, so that once I multiply those, I end up with just b squared over here. Okay, then I had to divide that on both sides to get b squared by itself. Okay, and since it's b squared, then I do the root of that, or square root in this case. If it's a 3, then I do a third root. Okay, that gives me the b value. And then once I get that b, I just plug it back into one of the original equations I made, and now I've got the a value. Okay, so now that's the final equation. That's what I start with. I'm starting with 6, and then I'm multiplying 5 in the equation. Okay, I'm going to do one more below that. Okay, so the difference with this one, the only difference with this one is that we're adding a number to the right. Okay, so instead of it just being the a times b to the x, we're also going to have a line on the side of it. So for example, that would be like if I took this 2 to the x and added 3, notice it just moves up. And what is that line that called that kind of goes right along the bottom of this? Asymptote. Okay, so basically it's an equation with an asymptote. Okay, so when I set this up, that y equals -1, that's the asymptote. So I have to include that when I set this up. Okay, so and what we'll do here is you guys can cross this one out, and we'll use all this space to solve this one, okay? All right, so first step, again, with this one is that's the equation, so that's what I'm plugging into. So for the first point, I'm putting negative 0.2 equals a. Remember, we're looking for a and b, so we don't know those. And then to the power of -1. But then there's also an asymptote, this k value. So after that, I put -1. Okay, so now I'm going to do the same thing. I'm going to get a by itself, except obviously I've got a little bit more to kind of do here to get it by itself. So first thing I'm going to do is let's get rid of this 1. So add it to both sides. Okay, so negative, anybody know what negative 0.2 plus 1 is? 0.8, yep. Now I've got a negative exponent. What can I do with a negative exponent to get rid of it? Remember the negative exponent rules. If I move it, I bring it down. So I bring it down to the bottom, and then it becomes positive. Okay, and it's just b to the 1, so basically b to the 1 is just b. But again, I want to get a by itself. So what would be the last thing I would need to do to get a by itself? How can I get rid of this b? Multiply both sides. So I multiply b on both sides. Cancels there. And now a is equal to 0.8b. All right, so that's my first one. Obviously, I had to do a little bit more because of that negative and because I've got an extra number out here. Okay, so what I'm going to do is kind of split this box, and we'll do the second equation right here. Okay, so now this one's a little bit bigger number. It's just 249 is the y here. Equals a times b, and then the exponent on this one's a 4. Okay, but then we got to remember the asymptote. Okay, so don't forget about the asymptote here. If you're given one. On the next page, there's a problem where you got to do asymptote, so we're going to make sure you include that. So same thing, add 1 to both sides. And now this becomes 2,500, conveniently. All right. Now it's not negative, so I don't have to move it to the denominator. So think about what we did on the last problem. What could I do to get rid of that? Not multiply, divide it on both sides. Because it's not underneath it, so I don't need to multiply it. It's right next to it. It's being multiplied. Okay, so now the new equation here is 2,500 over b to the 4th. Okay, so those are the two equations I'm going to use. This one and this one. So those ones will set equal to each other just like we did before. So I'll kind of do that step here. Okay, so now I'm taking the 0.08b and making it equal to the 2,500 over b to the 4th. Okay, so again, I just took these two and I made them equal to each other here. Okay, so what I'm going to do here is I'm going to do kind of similar to what I did up here. I'm going to get rid of the denominator. So I'll multiply that both sides. B to the 4th. Okay, so now b to the 4th times b will be b to the what? B to the 5th. Okay, so now I want to divide both sides by the 0.8. Okay, so I'm going to go ahead and divide that. 2,500 divided by 0.8. So that's 3,125. And what do I do to both sides to get b by itself here? Not a square root, but a what? What kind of radical? What will I put there? Yeah, so a 5th root. Okay. Do you guys know how to do a 5th root or like anything more other than square root in here? Which one do I type for something that's different than square root? Here's the square root. Yeah, the one right there that says x. So you got x and then the root. So what you have to do first is you got to type whatever that number is. So I type 5, and then I hit that root. And then you can see it turns into that little index number. Okay, so 3,125. So basically, what number do I multiply 5 times to get 3,125? It's 5. Okay, so b equals 5. Okay, so once I have b, what's the last step here? Which one should I plug it into? What would be easier? Yeah, this one. Just plug it into the easier equation. I could plug it in here, but obviously that would be something to do. So now I'm going to plug that in. 0.8 times 5 equals A. So 5 times 0.8, or 0.8 of 5 is 4. So now the final equation, what do I write first? Oops, sorry. What goes first, the 4 or the 5? 4, and then times 5, and then to the power of x. And there's one more thing. What's the last part? No, because it has an asymptote. What is the asymptote? It's that -1. So I got to put the k value included. Okay. All right. So I know that problem does quite a bit of steps. Okay, you just kind of have to work through it slowly. But again, remember, you're basically plugging in these points into the equation and then getting A by itself. That's the first step. Once you get those two equations, then you make them equal to each other, solve for B, and then that will help. Once you solve for get B, then I can just plug it in and get A. Okay. All right, so on that page, you guys are just doing that one and the one on the bottom. Okay, on the back page, you guys can cross out letter B on 118. Okay, and I'll go back to that if you need it. So you guys can cross this one out. And then on the bottom, you guys can cross out these last two here. So basically the last two, 8, 125, and then letter B here. That way you have all this space to do that one. Okay, this one on the back page is just like the one we just went over. Okay, also I'm gonna go over this one, kind of show you guys how to set this up. Okay, so Barnaby's grandfather is always complaining that 50 years ago, he could buy his girlfriend dinner for only $1.50. Okay, now that same dinner cost $25.25. Okay, yes, inflation. Okay, how could you write these as points? Okay, well, first, what I started with, okay, is $1.50. Okay, so that's actually my y value, my starting point, which is 1.5 or 1.50. Okay. Anybody, what would be the x value for a starting point? 0, because remember it's like the y-intercept. Okay. So the starting point's like your y-intercept. Okay. And then the last part is later on, it cost that same 150 became 25.25. And the 0 is like represents the beginning, right? So then every year is like the change in the x value. So what would I put here? No, not 0, because 0 is the beginning. This is now, which is what? 50 years later. Okay, so that's your x value, is the years. How much money you have, or how much money it costs, is the y. So now we're doing the same thing. Okay, we're going to come up with an exponential equation to explain the inflation here, but those are our 2 points that we're using. Okay, so assuming the prices increase exponentially and the same dinner never costs less than 20 cents, write the equation of a function that models the cost and relationship to the number of years from now. Hint, what is k in the problem? Okay, so basically what's the asymptote? So it says that it never costs less than 0.2 or 20 cents. Because it can't be free, right? We can't be the asymptote can't, the bottom can't be 0, because it would never be that. So we're going to say that the lowest it ever was 0.2 or 20 cents. So that's essentially your k value. So the k is that 0.2, okay, which is basically your asymptote. Okay, so now basically this problem is the same as the problem we just went over with the asymptote. Those are the 2 points, and then that's that y equals number. So basically it's, or I could write this as actually y instead of k. K equals y, same thing, okay? K and y, whatever. All right, so when I have to do my first step, okay, I'm plugging in this first point. The y value equals a. Again, what we started with. Okay, what actually we do? We know what we started with. What did we start with? Oh, actually, no, I'm sorry. No, we have to go through the steps. Okay, so here, okay, and then I'm plugging in the 0, okay, and b to the 0 equals what, by the way? 1. So basically this becomes, that cancels out, and a is equal to 1.5. So really, we didn't really need to solve for a, it's already there. Okay, so basically the only thing we need to figure out is the rate. All right, so I have a point. What I'm going to do is I'm going to take this point, plug that in. I already know the a, so I'm going to plug in the a to the equation. I don't know the b, okay, but I do know an x value here, which is 50. Okay, so now what I got to do is solve this. So I got to get that b by itself. What do you think the first thing I should do is? Huh? Divide what? No. Yeah, that's what. Don't touch the b. I don't want to mess with the b. Yeah. Divide the 1.5 first. Get rid of that. So 25.25 divided by 1.5. Okay. It ends up being like 16.83333. So I'm just going to put 83. Okay. Then it's b to the 50. And then what can I do to both sides here to figure out that b value? Do the root. So I got to do the root of 50. Okay, so I'm basically doing the 50th root this time. The 50th root of 16.83, which is 1 point, we'll round to the nearest hundredth here, 1.6, 1.06. Okay, so the equation then is 1.5 times the rate, which is 1.06, to the x, and then the last part is that k value, which is 0.2, 0.2. So that's essentially our equation there. That's the one we started with. That's given. This is the one we had to find by plugging in the a value and a point. And then that's the k value, the kind of the bottom line. So now, how much would you expect the same dinner to cost in 60 years? Well, what would I do with that 60 to figure that out? So it asks right here, how much would you expect the same dinner to cost in 60 years? Well, what would I do with the 60 to figure that out? Hey, you just plug it into the equation because that is your x value. The x is represented by the years, so I just plug that into this. So now it's just going to be 1.5 times 1.06 raised to the 60th, or 60, plus 0.2. Okay, so 1.5. And when you're dealing with money, it's not going to be pretty. All right, you're not going to get whole numbers and easy fractions to deal with. It will look like this. Okay, so that means that we're predicting that that same dinner in 60 years, if it's going at this rate, will be $49. And what should I round that to? Well, think about money in cents, right? So that's the tenth of the hundredth. Oh, so cents. 100, yeah. So that means round to the 8, and if there's a 1 here, it just stays 8. So $49.68. I mean, honestly, I went to Chick-fil-A the other day. I remember going to Chick-fil-A and taking my whole family and spending like $20. Like, which was even then was like a lot. I was like, damn, that's expensive. Because usually I go to fast food, I'm spending like $10, right? Everybody. Now it's like $40. And and I'm talking about like, that was like 3 years ago that I remember spending like $20. So inflation is crazy right now. Okay.
Chick-fil-A's like good deals like McDonald's does.
They do now, but they're not as good as like other places. Yeah.
And they use like actual.
I mean, it is good though.
It is better than my opinion.
All right, I'm gonna go over one more, just so you guys can see how to do the one on the back page. I don't want to leave you hanging. Okay, I know it's a lot. Okay, so here, 1998, Terre Haute, Indiana, had a population of 72,000. In 2000, the population dropped to 70,000. City officials expect the population to eventually level off, basically not get any lower than 60,000. Okay, so write an equation that models that. Okay, do we have an A value? Do we have something we're starting with? Okay, so there's our start, 72,000. Yes? That's what it is later, though. Because in 2 years later, it's that number. But remember, this is what you start with, the A value. Okay, so what we got to figure out is the rate. So we don't know that. So if we know 72,000 is A, then really all we have to do is solve for B. So I already know this part, the A. I don't know the B, but I can plug something into X and Y. Okay, now here's the deal. In year one, the first or the beginning, the beginning is 1998, but I'm not going to plug in 1998. Okay, 1998, the X value is going to be what? Because if that's the beginning, X equals what for 98? What number do we use to represent the beginning in anything? 0. Okay, when you were born, you were 0 years old. My son just had his first birthday, but when he was born, he wasn't 1. He was 0. So 1998 is 0. That's year 0. 2000 would then be what? 2. Because that's 2 years later. Okay? So that is what I'm going to plug in. That means that the X value is 2. In 2 years, what's the population? The 70,000. Again, this is why I'm going over this, so you guys, because I know that some of you guys will get stuck on this. All right, so X equals 2 because it's 2 years later, and then the Y value is the population. Okay, so that's what I'm going to end up plugging in. That's what you have to plug in to solve for B. And this one, you don't have to do anything further than that. Once you solve for B, then you just write out the equation. Okay, so you got one more step after that. Okay, let me stop the recording. I almost forgot I was